Hello, everyone. Do you hear my voice? All good? Hi. So my name's Parsa. I've worked here at Umain for about a year now as a mobile developer, mostly doing payment stuff. So if you're interested in how do I implement in-app purchase systems, or how do I implement Apple Pay, or Klarna, I'm usually your guy. When it comes to PayPal, Paul and team, sorry, haven't tried it yet. I'll make a commitment to it. This year, I will definitely put some energy into it. But yeah, that's kind of a little intro on me. And today, we are going to be talking about gRPC on iOS, right? So as you have with every single good engineering solution, you have to start with a very good engineering problem, right? So what's our problem statement? Networking, right? It's been the bane of our existence since God knows when, right? And it's always been about how do I get my data from my server over to my client as efficiently as possible and as correctly as possible, right? Bit of a timeline of what we've done so far. So we've had quite a few bangers, I would say. We've had Cobra, we've had RDA, some XML RPC. That one I've thankfully never tried. And we've had some decent ones. We've had SOAP, we've had REST, we've had GraphQL. And each one of them brought something to us. They taught us something. They fixed something for us. But they also had their own downsides, right? So let's take a look at a couple of the more modern ones that we're mostly used to. Let's start with the MVP, REST and JSON. Every single backend ever has at one point probably supported REST and JSON. It's the MVP, has served us quite well. You have your get, your post, your delete, and all of that good stuff for fetching your resources, right? What's the problem with it though? First things first, REST is just an architecture pattern, right? It's not trying to force you to write your resources in a specific way. It's just saying, these are the basic building blocks. However compliant you are with it is kind of up to you, right? And that results in people creating all sorts of shenanigans. The second problem with it is actually JSON itself. Now, you can do REST with different data types, right? JSON is just the one we've used the most, right? And take a look at this little user ID thing, right? I'm passing in a number, which can be fit in an unsigned int, so basically like an 8-bit thing, right? And in order to transmit that, I have to send 1, 2, 3, 4, 5, 6, 7, 8, 9 characters, each one of which is a byte. So in order to send 1 byte of data, I've had to waste 10, right? That's not the most efficient way of sending in over data, right? The third problem with it has always been that swaggers are never the source of truth. God knows how many times I've gone into a meeting with a person who's sworn up and down that they are compliant with their swagger, that exactly what they say they're sending is the thing they're sending, and it turns out it is not the case, right? And the problem mainly stems from it not being the thing that you compile to, right? So OpenAPI usually has some tooling. You can generate server code and client code based off of your Swagger, but it's never been that hard code. It's not really as enforceable as it should be, right? And then, again, REST and JSON, they came out 2000s, right? So it was built with HTTP 1.1. You can build it with 2, and you can build it with HTTP 3, but they never had streaming in mind when they built it. And they also built it with something that is relatively an ancient relic. So what came next? We had GraphQL, and for a while, it brought along some pretty fun ideas, right? So the problem with your resources being kind of messy, it got rid of that. It simplified everything to, hey, this is either a query and you're fetching the data, or it's a mutation and you're changing it in some way, shape, or form, right? It also defined a hard schema, right? So any resource that you want to get or anything that you want to modify, it has a proper schema, it has definitions, and it is enforceable both on the back end and the front end, right? Which was pretty great. And it also brought in fragments for us. So if you have something like a timeline or any sort of place where not every single information in your resource is needed, you can just not include it in the request. And that makes it pretty efficient in terms of like the data you pass along. So that was pretty good. But then again, problems as usual, right? So with GraphQL, one thing I like to say is that there's one right way of setting it up and about 200 ways of just shooting yourself in the foot. One example of it is an n+1 problem. So say we have this board and we want to fetch all of the list of users, right? Getting all of the users, that's just one SQL query, right? But if in the request, the client also asks for all of the tasks, what you end up being, if you don't have some sort of data loader on your backend, what you end up doing is you fetch all of the users, and then for each one, you go ahead and do an extra query, and that basically tanks your performance. Another issue is some people use GraphQL instead of SQL. Kind of a bad idea, but anyway. And then in terms of tooling, even though it is miles ahead of what we had with Swagger and OpenAPI, still sometimes a bit of rough edges. Now, the second problem is that it's still JSON, right? So even though, like, the nature of JSON is that the schema of it is always embedded within it, right? You have to say, oh, the key is user ID, the value is whatever, right? In case of GraphQL, even though you don't technically need it, because you've already defined your schema end to end, you still are using the format, so you're still bound to all of the inefficiencies that come with it. And kind of when it comes to like day-to-day usage, it is a bit of an overkill. If you just have like a normal app, a basic CRUD app that you just want to get resources from one end to the other, it might be a bit much. Honestly, it's better suited when you have like a timeline or something like that, where you have to just continue loading data and you have to optimize it as much as possible. And of course, didn't come out with HTTP 2 or streaming in mind. It does have streaming support, but it's more of an afterthought if you've ever tried to implement it. Not that great. So, what sort of solution are we looking for? We want something that is strongly typed, it's efficient, and also the transport layer is basically, less than a decade old. That would be nice. And has streaming and other requirements in mind. So let's meet our solution. Let's start with the format. So this is Protobuf. According to their documentation, sorry for blinding all of you with the very, very bright picture, but their documentation calls it's a language neutral, platform neutral, and extensible mechanism for serializing structured data. And what all of that means is basically you can have your protofile definition, and then from that protofile definition, for each language that you want to have, you can just compile those definitions into it. So if I have a protofile, I can get a .pb.swift, a .pb.go, and of course a Java, and a whole bunch of other languages as well. What does it look like? Well, this is what a Protobuf message usually look like. So you have the message structure, which is basically message is the equivalent of struct in Swift. You have your parameters, so like my point count, my feature count, my distance, whatever. You have their type. That type is important. That's kind of defines how big that message is. And then you see those numbers, 1, 2, 3, 4. The idea is that it defines which order these values come through. So it knows when it's serializing and deserializing based on both the type and the order. Like, okay, this first 4 bytes are always going to be the point count, right? So that's kind of how it makes sure that it doesn't need to send the structure along with it. That's how it gets around JSON's limit. The compiler looks a little something like this. It's called Proto-C. And the way it works is it has an extensive plugin system. So for each language that you want to generate files for, you basically just install the Proto-C plugin for. So for my example, I have Go and I have Swift. and you just basically generate the files. So we have the file format. How do we send it? Because sure, you've made it efficient, but how do you send it end to end? That's where the gRPC part comes in. So what does it even stand for? So the RPC part is pretty simple. It's remote procedure call. And the idea behind it is it's just an async task that you can call on somebody's server, right? So instead of all of the usual gateway stuff and that you go through and it's like, do this, do that, blah, 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 blah. It's just a function on another server that you deal with. Originally, it was created by Google. They put it out into the open ecosystem. And then Apple, very, very interestingly, took an interest and implemented the entirety of the spec in Swift from scratch. So it is owned by Apple and it is maintained by Apple. So at least the Swift implementation. The other implementations, they have a C core that basically generates all of the other type definitions from. It is based off of HTTP2 out of the box. It has streaming in mind. So if you see, this is what a sort of gRPC service looks like, right? I can have my RPC, that's basically the function. I have my function call, which is like get feature, list feature, blah, 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 right? And those values are basically my messages, the structures that I send in and what I get out, right? But then if I want something to be streaming, I can just say, hey, this is a stream that returns or a stream as an input. Now, that's all nice and all. And it uses Protobuf by default. However, you can use gRPC with other formats as well. And this is what it usually generates into. So you have my little route guide service from the slide before gets turned into something like this on Swiftland. You have your get feature, your input output descriptor, all that good stuff. So that was a lot of talking. Let's see some code. So let's start with this guy. So in my code, I have my service definitions as one package. I have my Swift, basically the code that I want to ship to my clients as another package, and I have my service definitions for my backend as a separate package, right? So if I go to my service definitions, I have this little nice structure. You can see there's my RPC. I can have enums, I can have optionals, I can have arrays and all of that good stuff. So if I say, I don't know, int32 UUID, that's definitely not how that works, but whatever. I can just add the definition here, right? And I can go here, and based off of my make file, I can just say, hey, go make my Golang definitions. And it compiles them out, and these get updated. You can see there's the new value that I just introduced. And if I want to generate my Swift files, then I can just go back in there, grab this, and do that. And basically the same thing happens for my Swift files. And you get the new value. You can tag, if you have something like you want to ship these out as packages, you can have your service definitions as one repo, and then once it builds, you can have one package for Swift, one repo for Swift, one repo for Go, and just tag them and just move them in your clients, right? Now, if I want to use it, how does it look in terms of usage? So I'm going to change all of these back and go to my little dummy server. Here's my little small Golang server that I wrote. The only thing it does is, hey, if the requester ID is 1, pass in that the order is done. If the requester ID is 2, pass in owner as my name, and then order status as pending, right? So all we're going to do now is I'm just going to say run. Okay, now the service is up. And in here, that's a bit of a first thing to come up. But let's do a nice little replace, and there you go. Nice little app. If I press run, I get back the status, and I get back all of the values, right? What does it look like on the Swift side? Well, you can see I've just defined it as a local package, so I can just pull it in, right? If I go to the code, don't blame me too much for the fact that it's a singleton. I was just trying to make something work. You can see this is basically the structure. I have this little event loop, and I pass it along, and I make the call itself, right? Unary, all that unary means is basically it's one way, whereas streaming is like, basically it's a socket, right? Now, all of this is fine and dandy. However, if you look at it, it's not the greatest Swift code ever written. And this is because when this was created, this was way before Swift implemented all of the async stuff, all of the task stuff, all of that. So you have this rather nasty like get or whatever to try to make it look a bit more modern. However, about a month before this talk happened, Apple released version 2. And that one is significantly better. So let's take a look at that one instead. Let's go to our little route guide. So here I am. This one is both the server and the client are written in Swift. And for my little route guide server here, I'm just going to create a small little message. Message, hello. Hello message. And this only has like an int32, ID 1. That's fine. And then I'm going to introduce a little RPC. RPC send hello. And it basically just grabs the hello and returns it. And returns. Now, as mentioned, Apple is the one maintaining all of this, right? Including a little plugin that they've written. So you can say, hey, for my little Protobuf service, generate both the client code, the server code, and the message. You don't need to leave Xcode. In fact, I'm just going to do a little command B. Let it run. Oh, why is there a problem? It's because I've defined a new thing, and I haven't implemented the stuff for it. So let's go do that. This is my function that I just defined in this route guide. And if I just go here, I can say, hey, var response is a route guide hello message. Response.id is the same as my request. And return the response, right? And that's basically it. It can recompile, and it'll run fine. But I said that it looks a bit more modern. So let's take a look at how it deals with something like a stream, right? So, for example, this list feature gets for its output, it expects a stream, right? So basically, this is what you can do. You can just say, hey, for my list of features, say I'm iterating through an array or something like that, right? I can basically just go through those features and say, try await response.write, and that just streams them out one at a time. That's how you get those values out. And then if you want to read values in, then all you have to do is say, hey, for try await point in the request that comes in. And there you go, you have your points, and you can do basically what you want with them. You have point, and all of the fields are there. And that's about it for our little demo. So the no, we're not done yet. We're not done yet. Don't rush it, don't rush it. So the pitch for the technology. It's great for analytics stuff. It is great for something like server-driven UI, if that's kind of what you're trying to get, because it's efficient, it's fast. It's super great if you want to do something like a map update, right? Because you don't want to keep sending a huge payload over for every single time the user moves on the map, say in a restaurant. I'm not mentioning names. It's built on top of HTTP2, it's strongly typed, it has streaming, and it is efficient. What's the anti-pitch? Well, first off, what is an anti-pitch? So the idea here is that when it comes to tech, there's always a lot of excitement about something new that comes along. but we should know what works and what doesn't work and make a sensible choice based off of its limitations and what works and whatever, right? In the case of gRPC, its main downfall is web support, right? It doesn't have web support out of the box natively. You have to use something like a proxy server to get it up and running. And your mileage may vary in terms of how good that is. In terms of tooling, it has been out for quite some time, so you do have a lot of support from tools like Postman and everything else. However, it's not on the same level as REST, but it is a thing where, well, REST has been out for like 25 years, so kind of hard to beat. And then the V2 things that I showed you guys do require, when it comes to at least Swift gRPC, it does require Swift 6, and it is a bit of a breaking change between V1 and V2. So, a bit of a teething issue there as well. Now, time for questions. Anyone?
Can we clap now?
Yeah, go for it.
Maybe I got confused, but if I'm not mistaken, since Proto 3, the field is optional, right? Definition. And then, if I'm not mistaken, in the example that you were having, it was, I think, the owner, which was explicitly marked as optional.
Yeah.
But the rest not optional. So I'm curious if it's handling it the other way around. So you basically need to mark the optional as an optional, and it's a little bit different.
So when it comes to Proto 2 versus Proto 3, did I close the original example? I think I might have. Open recent. Let's open that back up. For optional values, you do get a bit of if I go to response. Yeah, response.hasOwner. That's usually how it deals with optional values nowadays. It is, that part, I agree, is kind of confusing. They do say that it is compliant with the spec. However, it's a bit weird. The rest of the fields that I didn't mark as optional, something like status, you can see it doesn't say has status. It always has a value. This optional handling thing is a bit of a pain, and you definitely, if you prefer to do nullables and all of that stuff, it is always a great idea to have something in the middle that handles this. However, gRPC spec itself kind of forces you to always have a value, right? Because it's a matter of you have to fill out those X amount of bytes that go into each message, right? So if you have an enum, you should always pass in something like unknown or something like that, and it kind of applies everywhere.
Could you quickly go to the pb.straight and see what's the default value for that owner?
Yeah.
What is optional?
So the owner defaults to an empty string if it's not there. Yeah.
More questions?
My question is about decoding on the client side.
Yep.
Definitely, it's a binary protocol, so it should be more quicker in comparison to JSON decoding. Have you done any measurements, or maybe you can share some insights?
So I thought about doing some measurements for the TOG. However, the reality is it really depends on your JSON payload. So the bigger it is and the more nested it is, especially nesting is like the Achilles heel on JSON, it becomes significantly worse. So it's not a linear difference between the two of them. So it kind of depends. It depends on the type of data structure that you are deserializing.
Thanks, and a bit of follow-up regarding performance versus also the size. Is there possible to find the point where, like, definitely from one side, JSON, it's a compressible protocol. So despite the fact that it's verbose, it's transferred through the wire in a compressed way efficiently. While over here, it's a binary one, so maybe it's not that good in terms of compressing.
Yeah.
So what sort of bar has to be reached with this plain data of JSON in order to start looking or in this direction of RPC? Where is this point?
I mean-
To your vision.
I mean-
you can use gzip even on the binary format, and that makes it like you can just compress it even more. It's like, but in practice you don't need to.
Yeah, so when it comes to, he is very right. When it comes to these type of optimizations, like if you've gone for something like this, usually gzipping it as well is a bit of an overkill, to be honest. It is, however, true that gzipping like JSON is definitely easier. When it comes to like where you would use something like this, I would usually say something like live data is very, very good for this. Like that was why I was so heavily pointing out like streaming capabilities, right? So because when it comes to those type of things, you always have to create the connection and you have to do all of the keep alive stuff. When it comes to like raw just sending data back and forth, unless you have a lot of data, right? So something like analytics where you just have to, oh, user click this button or user click that button, and there's a lot of data that needs to go through. I still think something like JSON could be valid for like normal day-to-day use cases. It's only when you go sort of towards the more live side of things where it kind of becomes, okay, maybe I should consider something like this as well.
Can I say something about HTTP2?
Yep.
People don't know.
Yep.
You have header compression. Header compression means that if you send the same header again, there's only an integer that is sent. So that saves you a huge amount of data. That's much quicker. And the other thing is the turnarounds in TLS is also in HTTP much quicker. So you can do one-shot TLS. That's like latency. There's so many advantages to HTTP2 that I would never even dream of using anything else.
Mm-hmm. Thank you.
So I of course have a huge question here.
Yep.
How well does it work with skip?
That's a very, very interesting question. The basic answer is I haven't tried, because I haven't tried skip, to be very honest with you. However, I'm assuming that if it works, if skip lets you write all of the Kotlin stuff on your own, you can definitely do something like an interface that where you define your packages and implementations on the client for the Android side and one for the iOS side, and just pass it along there. Skip supporting it on its own, I have no idea.
There were a bunch of extra packages. Maybe it already does it.
Maybe.
More questions?
I mean, technically Firebase is the biggest user of, yeah, so you have all of the gRPC is very much used in Firebase, so if they've already wrapped that one, probably they figure something out, I assume.
Maybe that's something for next talk then. You can talk.
Maybe.
Somebody asked about skip at gRPC.
Maybe.
Someone to throw this to someone, so any question?
Go on then.
Oh yeah.
I don't actually have a question, I just wanted you to throw.
Okay.
Good. Then now it's time to rest. Or no, let's forget this word. But still, we are here at 19:30. Then we have a talk about amazing car model app. Something is very cool is waiting for us. So yeah, let's have a chat and then come back here.
Goodbye.